Welcome to this video lesson. Here we will cover basics of polynomials and simplifying expressions. Here we're going to learn about polynomials, but before that we do have to learn some terminologies. A term is defined as either a single number or a variable or a number and variable multiplied together. So for example, if we have a number 24, it could be multiplied by one variable, two variable, or even more variable. It could be multiplied by x, y squared, z, a, and many different variables. But these combinations multiplied together create one term. An expression is defined as a group of terms, and these terms are usually separated by a plus or negative sign. So to give an example, I can have 4xyz minus 3xy plus 4y cubed. As you can see, the first term over here has three variables and one number associated with it. However, it still counts as only one term because it's a multiplication of 4x, y, and z. Then it's separated by a negative sign here, and then you have your second term, and then that's separated by a plus sign by your third term over here. Now, an equation says that two things are equal. So usually we have one expression on the left side of the equal sign and one expression on the right side. On the left side, this expression has two terms, and on the right side we have one term over here. So whenever we use the word equation, we're talking about something that has an equal sign. A variable is a symbol for a number we don't know yet. We usually use letters such as x or y. We could use other letters, or we can use other symbols to represent a variable. A number on its own is called a constant. So example of that could be 4, 7, negative 20, and these are numbers that don't have any variables attached to them. A coefficient is a number that is used to multiply a variable by. So for example here, if we have 4x, it means that 4 is multiplied by a variable x. Therefore 4 will be our coefficient in this case. An operator is a symbol such as plus, multiplication, subtraction, and division that shows an operation. This is usually when we want to do something with the value. So for example, if I want to add 4 to 7, I have to use the addition sign here. If I want to subtract 3 from 8, I have to use the operator of subtraction, or the minus sign, to do it. Polynomial comes from the word poly, meaning many, and nomial, which means terms. So it really says many terms. And a polynomial can have constants, variables, and exponents. The exponent has to be a whole number. So it could be numbers such as 0, 7, 9, but it can't be fractions, and it can't be negative values. So it cannot be negative 4, it cannot be 1 over 3 or 1 over 2. So it can't be a rational number, and it can't be an integer, or pretty much negative values of the integer sets. A polynomial with one term is called monomial. An example of that is 4x cubed y. A polynomial with two terms is called a binomial, bi for 2. And in this case, I have one term separated by a minus sign from the second term. And finally, The last one we'll learn in this particular lesson is anything with three terms is called a trinomial. An example of that here is 3y squared, which is one term, separated by a plus sign by a second term, which is 47, separated by a plus sign by the third term, which is 3xyz. This example asks us to identify the following as monomials, binomials, trinomials, or neither. And for the last row, we want to identify the coefficients and the variables. I will do I will do 2 or 3 examples with you, and then I'll ask you to try the rest on your own. So the first one here, I have one term separated by a plus sign by a second term. My variables all have exponents, which are whole numbers. This one has a 2, which is a whole number. This one over here, if there is nothing on it, that means it's an invisible exponent of 1, which is also a whole number. So it is a polynomial for sure. It has 2 terms, and therefore it will be called a binomial. The next one, first things first, to check if it's a polynomial, I gotta make sure that all the variables have exponents which are whole numbers. So here I have exponent of 3, that's good, that's a whole number. I have 4 here, that's a whole number. And here I don't have anything, which means it's a 1, and that's also a whole number. So we know that much. I'm gonna erase this for now. And now I have one term over here separated by subtraction from the second term, and that is separated by a plus sign from the third term, making this a trinomial. Now for the last row over here, just to be able to identify everything, first of all I have an exponent here which is positive, and it's positive 1, so I can say that I only have one term, making this a monomial. And my coefficient is 5 over 8, and the 5 over 8 is being multiplied by my variable, which is x. Now, take about 2 or 3 minutes to do these questions, and then you can check your answers afterwards. Okay, let's go through the solutions here. For the first one over here, I have a number. It's not being multiplied by any variables, and we pretty much only have a number here, so we can call this a monomial. In this example over here, I have my first term separated by this minus sign, second term separated by a plus sign from my third term, making this a trinomial. And just to check, I have a whole number. I have y to the exponent 1, x to the exponent 1, and x to the 1, and these are all whole numbers, which makes this whole thing a polynomial, so we're good here. In the next example, just to check the exponents, I have a positive 1, and positive 1 here, positive 2 here, and these are all whole numbers, which is great. So therefore I have 2 terms separated by a plus sign, making this a binomial. This one over here, this can be written as 5 over 8 times x. It's pretty much the same thing. So I have one whole term. My exponent here is a plus 1, and it's a whole number, and since I only have one term not being separated by a plus or minus sign, this will be a monomial. Now this one is a little tricky. I have 5 over 8x. If you look before it in the description of polynomial, it says that you can't divide by a variable. Here I'm dividing by a variable, so that can't really happen. So this is actually not a polynomial, so I'm going to call this neither. Another way to look at it though is I can look at this as 5 over 8, and since the exponent here is positive 1, but it's on the denominator, it's the same thing as saying x to the negative 1 when I bring it to the numerator. And you can see that the exponent is no longer a whole number, therefore it's no longer a polynomial. Lastly, this case over here, looking at the exponents of my variables first, I have exponent of 1 here, which is a whole number, exponent of 1 over here, which is a whole number, 3 is a whole number, so that's great. And then I have 1 term, 2 terms, and 3 terms, making this a trinomial. In terms of coefficients and variables, I'm going to label C for coefficient and V for variables. So my first coefficient is square root of 4, which is also equal to 2. And the variable that is attached to is x. And then my next coefficient is 12, which is multiplied by variables y, z, 3. And finally, I don't really have a coefficient or a variable. I only have a constant value here, which is 0.25. You can also think of it as plus negative 0.25 as well, but in this case I'm just going to leave it as 0.25. The last thing we'll look at is like terms, and these are terms whose variables are the same. Here is one example with many different terms in which all their variables is the same. So in all these cases, I have my variables are x, y squared, and z. It doesn't matter what my coefficient is in this case. I'm only caring about my variables here. So variables here are x, y squared, z, which are exactly the same. X, y squared, z, x, y squared, z. In this case, they're out of order, but if you look at it, you still have x, y squared, and z. So we still have the same variables here. Here again, they're out of order, but I have x, y squared, and z. And finally here, I have x, y squared, and z. Now, if I had x squared y z, this will no longer be a like term, because even though it has the same variables x, y, z, it doesn't have the same exponent for all of them. So you have to be very careful when you're looking for like terms to be looking for both the variables and their exponents, and making sure that for each term the variables and their exponents are matching in order to identify them as like terms. Okay, now here we're saying that expressions can be simplified by adding or subtracting terms. So we'll do some examples of that a little bit later. But before that, what we want to try to do is to identify like terms in the following expression. So we have this huge expression, and we want to try to figure out what the like terms are. Here I'm going to use different colors to identify the like terms. So first thing we're going to do is look for the first term in our case over here, which is negative 5a. And the term here is negative 5a, but the variable is a. So I am going to look at every term that I have and see if I have anything else which has the same variable. The first one is negative 2, no variable. Next one has variable of b squared a. Next one has a variable of a. I'm going to highlight this because it's a like term. And then I have variable of b. And then I have another a. And then I'm going to look a little bit further. I see another a over here. And that's pretty much it. That's my like terms for the a variable. Now, my second term is just a constant value. It doesn't have any variables attached to it, and therefore to find its like term, I'm going to look at all the terms and see which other one is only a constant with no variables attached to it. So the third term over here has b squared a. I'm going to keep looking, and I see negative 12 over here, so that's another like term, similar to the 2. And I have a plus 1 over here as well, which is also a like term. Now my next variable here is b squared a. So I'm going to look and see if I can find another one which has b squared a as the variable. And you can see this one, even though the letters are rearranged, it's ab squared, but it still has b squared in it, and it has a, and therefore it is a like term. And if I look a little bit further, I can see the last term has a squared b, but that cannot be a like term because instead of b being squared, a is squared over here, and therefore I cannot call those two like terms. Now the next one, the variable here is b. So looking a little bit further, I can see that this term also has b as its variable and nothing else. So these two are like terms, and my other terms all have different variables. Moving on, my next one is a squared, and I see nothing else actually has a squared, so I can't find a like term to a squared. I then have a cubed, and I cannot find any more a cubed in there. And finally I have a squared, b squared, and nothing to match that. And my very last one is a squared b, which is my final term, and I cannot find any like term which matches that. Now to simplify simple expressions, the steps to do is first identify like terms. Then we collect like terms together. And finally we add or subtract like terms. So an example here could be 4x squared y minus 3xy plus 2x squared y. And the first thing we have to do looking at this expression when we're trying to simplify it is look for like terms. I can see that this term and this term both have x squared y as their variable. So well, first thing is identifying them, and the only term that's left is this one. So that one doesn't have any like terms. So first I identified it. Next I'm going to collect them together. So 4x squared y plus 2x squared y. And I'm going to leave the negative for the third term. And the last one is to add or subtract like terms. So my like terms are x squared y. And here I have 4x squared y plus 2x squared y. Whenever you collect like terms, after that you can think of it as adding or subtracting apples or oranges from each other. So in this case, I'm adding 4 apples to 2 apples, making a total of 6 apples. My apples are represented as x squared y. And I'm subtracting 3 oranges from that because they're not like terms, and I have to have them as separate terms. So in total I will have 6 apples, and I will have negative 3 oranges. Now this exercise over here is designed so that students can identify some misconceptions about adding or multiplying different variables or same variables. So what I want you folks to do is maybe write these questions down on another piece of paper, try them out, and after 1 or 2 seconds come back and look at the solution. Alright, for the first question over here, I have a plus a plus a plus a, and that is saying I'm adding an apple plus an apple plus an apple and plus an apple. So in total, I will have 4 apples, and that's how I would write the final answer. In the next question, it says that I'm multiplying 4 by b by b by b. So in this case, I'm no longer adding b's, so I can't say that I have 4 plus 3 b's, so I don't have 4 plus 3 apples, but in this case I'm multiplying. So here I have exponent 1, exponent 1, exponent 1, and I will have 4, which is my number. It will remain there. It's just my coefficient, and my variables is being multiplied by each other by itself, 3 times, so I will have b cubed. And again, b cubed does mean b times b times b, and therefore when I multiply it 3 times, I should get b cubed here. The next one says c times c. That's same as saying c squared. In this case over here, I have 7b times b times b divided by b. So I'm going to break this down. First of all, I have b divided by b, which is same as saying b divided by b. I can write it as a fraction, and any number divided by itself is just equal to 1. So these two can cancel out, and I can just say I'm multiplying here by 1, and any number multiplied by 1 is just itself. So I have my final answer as 7. The coefficient doesn't change unless I was multiplying the 7 by another number. Here I'm multiplying 7 by the 1, and 7 multiplied by 1 is just 7. And I have b times b, which is b squared. In the next example here, I have addition and subtraction of different terms. So first thing I want to do is identify any like terms. So in this case, I have 4d and d here, and I have e and e as my other like terms. So my first step would be to write this as 4d minus d plus 2e plus 3e, and that's collecting the like terms together, and 4 apple minus 1 apple is 3 apples, and 2 oranges plus 3 oranges is a total of 5 oranges in total. Now you could do this question right away. You can just give the final answer as 3d plus 5e, and after much of practice you'll be able to do this right away. But in your head you will still go through the same process of identifying that d and d are like terms, and you're doing 4d minus d giving you 3d, and positive 2e plus 3e giving you 5e in total. Now here in this question I have 2 terms which are separated by a plus sign. So just using BEDMAS, the first thing I have to do is take care of brackets and then exponents. can see that I can't really take care of any exponents here. I do have b squared over here, but really there isn't anything to do with it. So really the next thing to look at is multiplication here. And I have a multiplication signs right here. So I will have 4b squared over here. B times b gives me b squared. And the 4 is the coefficient. And a good form of writing it is always the number first and then the variables in going from alphabetical order. And I'm adding this to 5b squared over here. And now you can see that they both have like terms because b squared and b squares are like terms. So it's like adding 4 apples to 5 apples, and that gives me a total of 9 apples. So 9b squared. The next question here, we will use the same procedure to solve it. First thing to do is taking care of any multiplication. I can't really simplify any of the terms here because I only have one variable and one coefficient. So the next thing I will do is to identify like terms. I have 8f and 2f over here, and I have 3g and negative 6g over here. So first thing I'll do is collect like terms together. I get 8f plus 2f minus 3g minus 6g, and now I'm adding apples and oranges. I have 8 apple plus 2 apple giving me 10 apples in total, and I have negative 3 oranges minus another 6 orange giving me a total of negative 9 oranges. Now here I don't have more than one term. I only have the one term over here because I don't have any addition or subtraction. So I have b times 3 times b times 4 times b times b. First thing I will do is I will multiply the coefficients together. So those are numbers, and they are you can pretty much multiply them together. You get 12. And I have 1b, 2, 3, and 4 b's. So b times b times b times b is same as writing b to the exponent 4. Okay, so now I have a question here which asks for 5y minus y. They're already like terms, so I can simply do 5 apples minus 1 apple gives me a total of 4 apples. This one over here, I have 3b times 4b. These are all one term because I don't actually have an addition or subtraction sign. So I can just multiply everything together. So here I can multiply 3 times 4 together, giving me 12. So this is a simplified form of 3 times 4. And b times b can be simplified into b squared. So lazy mathematicians, instead of writing 3b times 4b, can easily write 12b squared. The next one says b times b times b times b times b. That is, when we want to simplify this, we write it as b to the exponent 5. The next one over here, again, I only have one term because everything there is multiplication, because 3a times 4b is same as saying 3 times a times 4 times b. So here I can multiply, to simplify, I can multiply the numbers together. I get 12. The variables together, I can't really get an exponent because I can't multiply a by b and get a to the exponent something else. So it just stays as 12ab as the most simplified form over here. Alright, for the next question over here, I'm going to identify like terms first. So here the first term has variable of x squared y. The next one has xy squared, so it's not like term. The next one has also y squared x or xy squared, so it's not like term. But I do realize that these two are like terms because they both have x and y squared as their variable. And finally I have x squared y, which is a like term to my first term. Okay, so now to add them, I get 4x squared y minus 2. I can reorder the variables over here because they're just being multiplied. It doesn't matter what they are. So for example, if you're multiplying 4 times 3, that's the same thing as saying 3 times 4. So if you're multiplying x squared by y, that's the same thing as saying y times x squared. So that's why we can kind of reorder these ones over here without any issue. Next thing, my next term is plus 4xy squared, and I'm subtracting 3xy squared from that. So finally I have apples on my first two terms now are apples. My last two terms are oranges. So 4 apple minus 2 apples is 2 apples, and 4 oranges minus 3 oranges is total of 1 orange. The 1 multiplied by any number is just itself, so for the best form of writing things, I'm just going to remove this one. I'll just rewrite it. So instead of writing 1xy squared, I can just write it as xy squared. Finally, for the very last one over here, I have 4 times a times b times a. That's one whole term over here, separated by a plus sign by another term. And this is separated by the third term. So, first things first, I have to simplify multiplication before doing addition. So 4 times a times b times a, only one coefficient or one number, so it stays as 4. I have a times a giving me a squared, and I have b left. I'm going to write everything else. I'm going to rearrange a squared and b just to write it as alphabetical order. Makes it a little bit easier. And now I can identify my like terms. I have this and this as like terms. So this one, I have a fraction over here. So what I can do is I can write it as a common denominator of 2 for both. I have a squared b over here, and here I have multiplied the denominator, which is usually just 1. If there's nothing there, then it's 1. I multiply the denominator by 2, so I have to multiply the numerator by 2. So this becomes 8a squared b and minus 1 over 3ab squared. So now I have 8a squared b over here. And I'm adding 1a squared b, so 1 apple plus 1 apple on the numerator. And when you're adding fraction, the denominator stays the same. So I get 9a squared b over 2 minus 1 over 3ab squared. Better form of writing this is just 9 over 2 a squared b minus 1 over 3ab squared. Note that you can also write this as 1 over 2a squared b minus 1 over 3ab squared. Alright, let's do some practices now. So what we want to do is simplify these expressions over here. The first one that we have, I have w minus negative 10w. So these are pretty much like terms because they both have the same variable. So first thing I have to do is take care of the bracket over here. Looking at the bracket, I can't really do anything. I can't really simplify anything in the inside. And what I do notice a little bit later, because after that I have to take care of multiplication and division, I have a negative sign multiplied by another negative sign, making this a positive. So I can rewrite this as w plus 10w, because once again, negative times a negative gives me a positive. And then once I'm here, when I add them, I have 1 apple plus 10 apples, giving me a total of 11 apples. And it doesn't matter what variable we're using here. It could have been x, could have been w, could have been wx squared z to the power of 100, and it would still give us the same answer at the end, as long as they were like terms. The next example over here, I will look at my terms first. So these two are like terms. These two are like terms. But before adding or subtracting, I have to take care of brackets first. I cannot really simplify this bracket over here. So next thing I will look for is multiplication and division. I can simplify this multiplication over here of a negative and a negative. So my next line will be 6x plus y plus 3x minus y. Don't forget your equal signs. And then I get equals, bring like terms together. So 3x plus 6x plus 3x plus y minus y. And I have 6 apples plus 3 apples, giving me a total of 9 apples. And I have y minus y, so that's 1 orange minus 1 orange. So that's like you getting 1 orange, gaining it first, that's the plus, and then eating it, that's negative. So you're left with 0 there. So you can write it as plus 0, but for good form, you should not write that in, and you should just leave your final answer as 9x. Okay, for the next question, you can see that I have a lot of variables in here. So the first thing I want to do is actually just use bedmass to simplify things as much as possible before collecting like terms. So I have a bracket over here. I cannot really simplify inside the brackets, but I have a negative and a negative that multiply together to give me a positive here. Keep that in mind. I cannot simplify anything here, nothing here, but here I have 4 times x times y times x, and I can simplify x times x and make that into x squared. So here I get equals 4xy squared minus 3x squared y, because I can't really simplify those yet. And then I get plus 4x squared y, because that's multiplication of x and x. And then negative times a negative is positive x squared y. So now I can collect like terms. I have xy squared and x, and that's the only xy squared that I have. And I have x squared y, and x squared y. So my final answer would be 4xy squared and negative 3 oranges plus 4 oranges plus another orange. So that will take me from -3 to +1, and then another one, giving me a total of 2 oranges at the end. This example over here, first I will look to see if I can simplify anything. I cannot simplify this term, nor this term. So next thing I will do is try addition by collecting like terms. So I have these two terms that are like terms because they both have variables x and y, and this one has variable xy squared. So -3 oranges plus 3 oranges. It's same again, getting 3 oranges and eating them all. So these two cancel each other out, and you're just left with -1/2 xy squared. Over here, in this expression that I want to simplify, I don't have any brackets. I don't have any multiplication within terms that I can simplify. I can't simplify this any further. Can't simplify this any further. This nor this. So what I will do is collect my like terms. I have these two with variable x squared, and these two as variables x. So to write this down, I will have 1/2 x squared plus 3/4 x squared minus 3/4 x minus 1/4 x. Now I'm dealing with fractions. So what I want to do is get a common denominator, but first I'm going to change the way I have written things. So instead of writing 1/2x, I'm going to write it as x squared over 2. These two here are equivalent because this is on the numerator, this is on the numerator, and this is on the denominator. So you can multiply the numerators together and you get x squared over 2. And I will add 3x squared because 3 is in the numerator and x squared is in the numerator, and the only denominator that I have is 4. And then I will subtract 3x over 4 minus x over 4. Now it's a little bit easier to actually see how I am doing the fractions. I will get a common denominator here of 4. You can see that I would have to multiply 2 by 2 to get 4. So then I have to multiply the numerator by the same value, and here I will get 2x squared plus 3x squared. And here I will have 4 over here, and I will put a plus over here, and there's a good reason why I'm doing that. It's because I'm going to separate this 3x over here, and I'm going to put this as -3x over here and -x over here, and I will get a total of 5x squared on top over 4 plus, and I will have -3x minus x, which gives me -4x over 4 over here. So now to simplify this as much as we can, or to write it in better form, I will write this as 5/4x squared. And here I have a plus multiplied by a negative, which gives me a negative. and I have 4 divided by 4, which gives me 1. So it becomes 1x. So I don't even actually have to write the 1 because 1 multiplied by anything is just 1. So I will just write x over here. And that will be my final answer.